Hello, everyone. I'm Adrian Sanabria, host of the Enterprise Security Weekly podcast and founder of the Defenders Initiative. Welcome to this webcast sponsored by runZero. I have two guests with me today, Tod Beardsley, VP of Security Research at runZero. How you doing, Tod?
Hello, Adrian. I'm doing great.
Glad to have you here. Also with us, HD Moore, CEO and founder at runZero. How you doing, HD?
Pretty good. Hey, folks. Glad to be here.
Always excited to have you guys on. I always learn something when we do one of these. And today we are talking about attack surface management. Before we jump into the meat of the conversation here, I just want to direct the attendees to the blue bubbles down at the bottom of your screen. The first one there, that is the chat button. So you can chat with us, you can share where you're dialing in from, you can ask questions, most importantly, through that chat interface. I'll be monitoring that throughout. I think last time we did this, Tod was also monitoring as we went through the conversation. And we will pull in your questions as you put them in there. Don't save your questions to the end. I find it more useful if we bring up your questions within the context of the conversation that we're having. The other button I would like to direct your attention to, the third one down there, that is the handouts button. And we do have some slides for you to check out there, some diagrams, some items related to what we're going to be talking about today. So go ahead and grab those now. I'll try and remind you again as we get towards the end of the conversation to check those out, but you can grab them at any time. All right, with that, let's jump into it. So attack surface management, I think the place we have to start is in defining this kind of evasive term, HD. When you're thinking about attack surface management, what is it to you?
Like, step back a little bit, a couple of years, and folks would really refer to external attack surface management as being attack surface management. It's very much like stuff outside your firewall that you need to know about, which may include domains, websites, TLS certs, applications, SaaS, things like that, cloud, on-prem. These days, though, attack surface management really includes everything. It includes your vendors, it includes your supply chain, it includes your identity, it includes your SaaS, your IAM, everything in between. So when we talk about ASM, in this podcast, in this show, really what we're talking about is every single piece of exposure that your organization has, no matter where it is, who it's exposed to, whether that's exposed internally, externally, through the cloud, through mobile, et cetera.
Yeah, and we are going to share some slides from time to time here, so you can kind of visually see that what we're talking about here. But yeah, basically any way your company can be caused pain and or losses, it sounds like.
Yeah, it's basically your stuff. Like, where do you know where your stuff is? Where is it? Can someone else get to it? Mm-hmm. Do you know about it before they do?
Yeah, exactly. Name of the game is finding those gaps, right? And so the current state, you've already mentioned external attack surface management. There are a lot of tools out there that are just one thing or the other. They just look at the outside in perspective. Some only look at the inside perspective. Some will actually scan both, but don't really put the two together. So where do you see the tool space kind of, what's your vision for where we need to get to? Because personally, I remember back in 2021, I did a product review of about a dozen external attack surface management tools. And one of the things that struck me is, man, it would be great if I could connect what I'm seeing from the outside to what I'm seeing from the inside. That would save me a lot of time having to hunt the stuff down.
Absolutely. I mean, over the last 5 years or so, we've really seen a change from ASM being external to really being everything. And what that looks like in tooling is that it's not just doing external scans or domain discovery. It's pulling in data from integrations. It's connecting to your various clouds. It's getting data from things that you can connect to, link to tell you about stuff that otherwise isn't be visible. The external perspective is tricky too, because if you find something, let's say you find a domain name that is owned or a subhost that's owned by you, it's on the internet someplace, you don't know who in your company actually owns that thing. So it's really difficult to find the owner and get it remediated. Oftentimes you tell someone, hey, you've got this exposed WordPress server, like, great, we don't even know who owns that thing, who manages it. We know it's in our DNS somewhere, but that's about it. Mm-hmm. So what we've been trying to do is really look at it from the other way, which is that we're fantastic at internal asset discovery, fingerprinting, exposure management at runZero. So we've actually been looking at, can we use the fact that you have comprehensive internal mapping to then find your external from the inside perspective. And the great thing about that is if you put those two things together, you already know who the owner is because you already know where it lives internally. You're not trying to chase down who installed the WordPress. You know exactly what internal server it belongs to start with. So I think that part's really interesting. I think often we talk about attackers having only need to find one thing and defenders need to know, defend against everything else. There actually is a superpower that defenders have, that you actually have a great way to get visibility of your own internal assets that the attacker doesn't. So leveraging the fact that you have more visibility and better access control to your internal side of your environment really helps you get the edge against an attacker going after your external side.
And you talked about finding external stuff from the inside. Can you give some examples there? Like how would you know from an internal scan that something is maybe exposed externally?
Yeah, sure thing. I mean, everyone's familiar with tools like Nmap where they scan stuff and they say this IP has these ports open, right? We do something a little differently. Like the runZero scan engine, we actually trick devices into telling us about their other IP addresses besides when we're scanning. So if you're running Windows, we've like two to three different ways to get the other IPs of that system. And that includes things like IPv6 addresses, tunnel IPs, VPN adapters. So for example, if you want to find out who inside your internal environment has a Molbad VPN installed, we can actually find that remotely unauthenticated on the network just by querying DCRPC endpoint mapper, which is pretty cool. But it also lets us find cases where the same device is connected to more than one network at a time. So there's really three ways. There's getting the device to tell us about its IPs directly, or leaking it out of SNMP, things like that. Then there's looking for the same unique ID in multiple places, saying if we see the same asset in 5 places, obviously that asset is joining those 5 networks together. Therefore, it is connected to those 5 systems and it's a bridge, right? So if you see it external and you see it internally, that effectively becomes another way from outside to inside in your environment. And you do that just by identifying the unique asset in both sides. The final way we do it, which is really cool, is we'll do unique fingerprinting of services internally that should be globally unique and look at the entire internet to see if there's a match. So the super easy example is you can get the TLS fingerprint or remote desktop of all your internal remote desktops, and then search the whole internet looking for any reference to those TLS fingerprints. If you see any hit whatsoever, you've got a problem. Like there's absolutely no reason why you'd ever find a TLS fingerprint for an internal RDP server on the internet unless that device is directly exposed. And of course, the great thing about that is when you find it externally, you already know where it is internally.
Also, if that internal like TLS certificate is found on the internet 1,000 times or 10,000 times, it's probably not there 10,000 times. It's probably just a duplicate TLS cert, which we've run into, right, on client side. So you'll find this a lot in like devices that you install. It's like your 1U device that has a TLS thing, and it's like it's some turnkey thing, or it's an integration from a partner or something like that, or your building management or something along those lines. You will see those pop up across the internet. And so it's not necessarily that it's your thing that's exposed to the internet, but your thing has many, many, many clones out on the internet.
That's a good point. So this technique identifies clone systems. So you have a gold image you've cloned 50 times and you haven't changed like your SSH host key, for example, we'll find all of those. So it's not just TLS. That's the important part. TLS is obviously the easy way to do it that a lot of folks are familiar with, but you can use the SSH host keys. During the SMB2 negotiation process, you can leak out what's called the server GUID, and that GUID is unique until a machine is rebooted. So if I find that SMB2 GUID on the internet, then I find it internally and it's within the same time window, that is the same machine. So kind of what Todd was getting at is if you find the same thing in more than one place, and there's only 2 of them, one internal, one external, you've got an exposure. If you find it all over the place, the internet and internally, it's a hard-coded key or otherwise like clone system. And if you find it only in some places and not in other places, you have kind of these weird middle grounds, right? Like you have to use heuristics to figure out, is it a hard-coded key? Is it a clone system? Is it something that the vendor hard-coded? But the great thing about this is doing the work allowed us to identify a ton of new vulnerabilities because we find a bajillion cases where vendors have hard-coded crypto keys just by doing the analysis of this work.
Yeah. Yeah, and it reminds me of a time I knew of an organization that actually set up a SSH honeypot, and they collected keys just to see if they would get any of their own keys, any internal SSH keys externally. Then they knew they had a problem, right? That something had leaked out at some point.
That's great. A lot of folks don't realize when you're SSHing to a machine, you're sending your pub key by default. And so if someone knows what your public key is and you connect to them, you can identify it. So you can actually dox attackers by taking the list of GitHub keys from GitHub for all the users and then looking at your inbound logs and saying, okay, it's this GitHub user trying to log into my system, which is great.
Yeah, yeah. So something else you mentioned, just going beyond even your own IP address space. I think this is an important concept for folks when talking about attack surface management, asset management, moving beyond things that just have IP addresses. And you mentioned third parties, right? So maybe talk a little bit about how runZero turned into an asset management tool with a scanner into something that cares about what your SaaS is, what your third parties are.
Yeah, absolutely. So early days, started the company because I was doing pen test work, and we kept breaking into companies who had great budgets and lots of security by finding things they didn't know about. So we'd find something that the team didn't know about. It would obviously be, not managed, not monitored, no EDR, et cetera. It'd be an easy jump point. Or we'd find devices that are multi-home, but let us get into an environment from a different environment where we shouldn't be able to. And that was kind of the genesis for the kind of runZero approach of finding all the stuff and looking for the interconnectivity. Then we started expanding integrations to pulling data from all different third-party systems, whether it's an asset with an IP or just a device type. These days, we pull data from everything. So you can take any arbitrary object in your world and make it a runZero asset through the custom SDK. You can do, OT devices. You can do things like bridges. You can do SaaS applications. You can do MDM clients, anything in between. So we've got pre-canned integrations for quite a lot of these, but you can also build your own, and it's a really simple SDK and/or API, depending how you want to wire it up. And you can basically just take any device anywhere, any device anywhere else, and automatically match, merge, and track those things over time. So things like SaaS, you can identify by pulling a list of applications from like GitHub backend. For identities, we pull things like Azure AD or your LDAP AD, and then build assign owners to every asset. So you know exactly what asset is owned by which user. So if you're trying to remediate something, you know who to go chase down and resolve it with.
Yeah. I think this is a big challenge for a lot of organizations in that, talk to some folks who almost don't even want to know what their other assets are because they have such a, like they have a traditional data center, they have a lot of internal assets, like, they don't even want to know about their shadow IT problem of all their SaaS problems because they feel like they're never going to get finished with their internal stuff. And I think there is some danger there of getting blindsided by some of the gaps that you have. I think in recent studies from the latest Verizon data breach report, something like, and also from some cyber insurance reports on where they're actually seeing policies pay out. Anywhere from 30 to 40% of attacks we're seeing are from third parties getting compromised,
Absolutely.
not you directly.
And Todd, I think you've got a note in the handout about the top 4 initial access vectors from the Mandiant report from this year. That was pretty eye-opening too.
I do indeed.
So what's surprising about this is, Mandiant put out an annual report, and they say, here's the things that were initial access. I think the slides, there we go. If you go back, I think one, or this is good. Do you want to talk through this, Todd?
Sure, yeah. So yeah, in the Mandiant report, and I'm very excited to see what the next round of reporting will look like. A year on, almost a year on, right? But the thing is that attackers generally for initial access, all of the reports were very breathless and saying like, oh, attacks are up. Attacks on vulnerabilities are up. They're up to, they're almost to 25% now. It's like, okay, cool. So 75% of the time, no vulnerabilities required. Okay, got that. But sure, it's up. But it's up, and also it's almost entirely concentrated on 4 particular devices, right? A PAN-OS device, a couple of Avanti devices, and a Fortinet device. These are the things that are on the edge of the network that are responsible for securing the edge of your network. So like it's
supposed to be responsible for securing.
Right. And
not being
I don't want to jump on these
attackers,
vendors like in particular, but like this is the pattern where it's like, oh, well, the attackers like are taking their time. They are finding their vulnerabilities. It's not like they're, good citizens who are reporting them and filing CVE reports or anything like that. But they are definitely, really concentrating on at least for that tactic, like why bother with web servers, right? Or anything like that. Just go after the edge of it. Go after the firewall, the proxy, the VPN concentrator, things like that. So it's and it's something that we've talked about, I think, for a long time. Like, oh, well, you need a firewall for your firewall, and then maybe put a firewall in front of that firewall, and then you'll be secure.
Defense in depth, Todd. Defense in depth.
And that's what we mean when we say defense in depth, right? Just more firewalls. No, that's not what we mean. But I will say that, like, it is important though to understand that, like, yes, these exploits are scary and the vulnerabilities are scary. They're almost always like truly ODay, right? Like the first indication that anything is wrong is you have shells, that you're detecting. And so, those are scary, but also it's only about a quarter of the initial access successful, breaches, start there. Like the other 75%, far and away, it's user in the environment clicked on something naughty that they shouldn't have clicked on in an email. Is it the user's fault that the entire organization is breached? No, it's not. People be clicking all the time. And so it's hopefully the responsibility of the IT security group, whoever is, tricked into taking that role, to make sure that like your internal structure, right, as, proper segmentation, not everyone is running as admin on their local, all the normal eat your vegetables kind of stuff that we tell people out there, and that far and away, gets you ahead of the game, right? And then the things that HD was talking about, like, oh, well, let's just find the things that the defender, like the asset owner, the enterprise owner, doesn't know about, and that's where we're going to go. And this is exactly how attackers operate too, right? Like once they have a foothold on, one end user's machine that has, path to all of the other stuff, find the interesting stuff that probably hasn't gotten a lot of attention lately, things that don't have EDR, things that are end of life, things that are IoT, that can't really have like an onboard EDR. There was a question in the chat. Speaking of that, I'm totally hijacking.
Yeah, from Andre. Yeah.
Yes. There was a question in the chat of like, how does runZero help monitor and protect IoT devices like cameras and, I don't know, fish tanks, which we have seen in enterprise networks, and the
casinos of fish tanks.
Casinos do love their fish tanks. I have a slide up right now. It's just a real basic. Yes, we do fingerprinting, but I do think that runZero. The reason why I came to runZero initially was because the fingerprinting is rad. It is bar none, right? Like the coolest thing for me as a nerd, as like a packet nerd, right? Like I love the fingerprinting a lot, and we get to these pretty good and clear, pictures of your network through runZero, right? Like most vulnerability scanners, when they find an IP camera, they're like, hey,
I love that you're building slides for things that I talk about all the time, because I bring this up constantly. Like again, when I did product testing for vulnerability scanners, and they scan my ubiquity stuff, which ubiquity stuff is ubiquitous, so everybody should know how
it's
to
in the name,
right? Right, it's in the name, and it's just like Linux. Like which thanks. Is it a mainframe? Is it a Samsung fridge? What is running Linux here? Like it would really help me if you told me it was a wireless access point or a router or something.
We spend a lot of cycles trying to nail down, not only is it, the operating system, which we care about, but what it is, what kind of thing is it? We have a bunch of classification going on, like in the that's presented to the end user through the runZero console, and all of that is magical, I will say, in a nice way, not in it's in an effable way. Like it is all repeatable. We know not in an AI way we get there.
Yeah.
So it's pretty cool, and just having that, like, if you have nothing else, right? Other than like, oh, here's like a pretty good profile of all of the things on, your internal network that all of your devices are saying are the internal network. Like that gets you a long, long way toward being like in a defensive position.
And something. Go ahead, HD.
I think we're kind of chatting a little bit about the vuln management side, because a lot of folks will tell you what they don't like about vuln management is you get a ton of vulnerabilities and you don't have time to fix them. So what do? You prioritize, et cetera, et cetera. Like we have a very contrarian take that kind of ties to the fingerprinting, which is like most of your vulnerability data you're getting is garbage and doesn't help you at all. And it's missing half your devices anyways. So if you're prioritizing just what you're getting from vuln management tools, you're probably missing half your stuff and you're probably prioritizing the wrong things and you're still being overloaded. So what's the point, right? So where this comes back to fingerprinting is like when a new vulnerability comes out, let's say another 0-day in Palo Alto device, like you don't care about whether that device is patched. It's not patched. It's on the internet. It's running Palo Alto. It's getting exploited. There's literally nothing you can do about it, especially if that's also the way you access your network. So what you need to know that second is, do I have Palo Alto devices? Where are they? Can I do something else to mitigate them? Can I put IP ACLs in place? So it's just knowing where that particular technology exists very, very quickly, that's the most critical way to avoid getting breached these days, because attackers are making use of 0 days so often that it's not like you can apply a patch for it. If you're waiting for a vulnerability management vendor to create a check for it, and then for the check to go out, and then for a scan window to complete, you're not going to be able to respond quick enough. You really need to go to this kind of like instant model of like, there's a bug in this obscure technology I've never heard of before until today, but I need to find out where it is in my environment as soon as possible and get it mitigated and start doing, blast radius analysis. And I think that's kind of the big disconnect between vulnerability management and kind of our view of the world, is that you don't necessarily need to go through and figure out what you're missing patch-wise. You need to figure out where that technology is during the window of exploitation.
Yeah. And, we capture all this stuff all the time with our regular, normal, operation of runZero explorers, and it all gets fed to the console. And so we have this database like of the state of your network at that moment, right? Like we're not waiting around for a vulnerability signature that may well be in the form of log into a Windows machine and check the registry and see if the patch is installed. Like a lot of times for an EDR solution, that is the vulnerability check, which means you can't know until you've done your scan, and that might take hours to days, right? With this approach of like, well, if I just know what everything is in my network, I can then scan. I can query.
Yeah. Why would you wait?
I don't have to go scan, right? Like I already have it right here. So.
Yeah, could you bring that slide back up again? I just want to kind of reiterate that, the one with the timeliness where stuff was in green when it was.
Oh yeah, sure.
Yeah, the Mandiant one.
Yeah, this is all an experiment, by the way, in Slide DJ here. So hopefully people find it useful.
You're doing an excellent job, Todd. Yeah, so just to highlight here, like what you've got in the columns across here. This is something I talk about all the time. This is yet another one of these slides that you've created that visualizes something I talk about all the time, which is everybody finds out on the same day when the vulnerability is disclosed, right? So what happens when you have to wait on somebody to build a vulnerability check, for that check to go through QA, for it to go to production, for your scanner to once a day, maybe you're scheduled once a day to grab new vulnerability checks. And then whenever your next vulnerability scan is scheduled, then it runs, and then a human has to look at the results after that run is done. And I remember I used to have vulnerability scans that would take over 24 hours to run, which is how I know that some scanners will kill that 9 at the 24-hour mark. So yeah, anything you see like in white or in I guess that's orange here. Yeah, you're finding out way late. In some cases here, it's like over a week after vulnerability disclosure that maybe you have it on your systems, and right. Anything over 24 hours is kind of late. We see a lot of particularly like the Pan OS, the FortiClient, the Edge appliances. Those things start getting attacked within hours.
Yeah. And were attacked like 2 weeks ago.
Yeah.
So, the key distinction here is the authenticated column. That's like, can the scanner find it without having credentials set up ahead of time? So if you are using a standard vuln scanner and you just point and shoot, you don't really know what's in the network, you just point and shoot, do your thing, you're going to get only the unauthenticated checks, because you don't have any way to authenticate these devices, especially things that are not domain joined, like your Palo Alto network device. Like, unless you specifically configured a Palo Alto credential inside of your tenable scan, it's not going to do a check for Palo Alto for the authenticated side. So what you'll notice here is the unauthenticated side takes a lot longer to build. They're much harder to build. They're almost like building an exploit. They're very tricky to build. They take a lot of time. And sometimes people just never ship unauthenticated coverage at all. So if you're doing a scan in your network and you've got a part of the network where you can't authenticate to because of M&A, a different domain, connectivity, whatever have you, like, you're just not going to get results for those unauthenticated assets. And you're also not going to get a note telling you don't have results for it. So it's those kind of like landmines that we really worry about. So that's why we really focus on, like, can we identify the technology during the window of exploitation that second and tell you about it? And that all builds on having amazing fingerprinting and really good integrations from everything else that knows about your environment to pull it in together.
It looks like maybe we should define 0 days.
Andre is calling us out on our lingo, so and that's totally fine. Geez, I don't know, man. So like an unknown vulnerability, I guess technically nobody knows it, including the bad guys. 0 day. So traditionally, a 0 day vulnerability is they only last for 1 day, because other than that, then it's 1 day, right, or 2 day.
Right.
But 0 day vulnerabilities are vulnerabilities that are typically known by attackers and not known by the provider of that technology. Typically, right? Like, and that's when they become known, right? Is like somebody noticed it, right? So O-days can last in reality. O-days last often, weeks in that zone right now, where the attacker is quietly like owning things, right, and not lighting up everybody's, detection mechanisms. But I mean, the term itself is, it has two problems. One, it sounds cool, so people say it all the time, and then two, it's like pretty ill-defined, and like depending on like where you are possibly in your career, you may define it differently. So it's not a great term, but we use it all the time. Right?
If I can take a crack
for something that doesn't have a patch, right? That is the easy shorthand.
So if I can take a crack at it, I think the significance here is information asymmetry, right?
Mm-hmm.
Like somebody knows something they can use against you that you don't know about, so you can't defend against that by mitigating it with a WAF rule or applying a patch or what have you. So on day one, you can get hit with a 0 day and not know about it. So all of a sudden somebody's got shells and you don't know how they got in. And maybe that's how you discovered that there was a vulnerability in one of your products.
Conceivably, like you could have cool instrumentation, right? That will say like, oh, a shell just happened, right? Like you might be able to so in the example of there's some 0 day, let's just say it, 0 day on your edge, VPN concentrator. Like you will never detect that you have no mechanism to prevent the attack, right? But you may have mechanisms to mitigate it through, geofencing rules, right? Like I don't want anyone from Kazakhstan, logging into my VPN concentrator because I don't have any employees in Kazakhstan. So why would I need that, right? You can do something like that. You might have instrumentation that says like, oh, look at that, a shell just popped up on this thing, and I wasn't expecting to see, port 4444 opened to outbound from there, right? Like I wasn't, so like pop that in your SIM or something like that. So there are often ways to like at least notice or mitigate against 0 days. They're not magical, right? They're not magical mm-hmm. like super Hadouken attacks or anything, but they are they're difficult to detect and difficult to like easily patch against, right? There's no like rollout fix for it.
One of the reasons the network devices are so popular for these attacks is that you can't really put telemetry on them. You can't put an EDR on your firewall most of the time. So if somebody does pop it, you really have no other way to determine that they're there besides getting lucky and seeing the logs. If they just sit there and stiff credentials for a month, like you're not going to see it very often. So we're talking about this so much because one, it showed up in the M10's report as being like, the most common initial access, but we've just seen this becoming much more common as the way that attackers break in. They find a bug that either is unknown to the public or in the more recent case, Fortinet patched a vulnerability, didn't tell people about it. An attacker found the vulnerability, started exploiting everyone in the wild, and then Fortinet had to tell everyone, yeah, you really should have applied that patch that we put out 2 weeks ago. It's like, well, kind of missed the point there, right? Which is that you need people to know about that to be able to respond to it. That's kind of the standard these days. You've got devices with limited telemetry that are getting compromised through bugs that no one knows about yet, or that at least your defenders don't know about, that there is no check for. And as soon as you find out something's happening, you need to be, you don't want to be the person who can't outrun the bear, right? Or at least outrun your friend. You need to be able to at least run a little bit faster and make sure you don't end up on the next ransomware site tomorrow morning for extortion.
Yeah, for sure. Yeah, I hope that's. I think we extensively defined 0 day there. But generally, it's like in that Mandiant report. They put out a report on this where the disclosure of the vulnerability is malicious use. Like if there's coordinated disclosure and the patch comes out at the same time you find out about the vulnerability, I don't think I'd really call that a 0 day. Would you?
Well, one thing that's interesting is CISA-KEV, Todd knows way more about this than I do, but if you see a CISA-KEV get published on the same day that the vendor put the patch out, that's a guarantee that thing was being exploited in the wild at least 2 weeks to a month beforehand, at least. So you're already 2 weeks behind the ball at that point.
Yeah, CISA-KEV is a late indicator.
It is a late indicator, which is why it's suspicious when they are published on the same day as a vendor patch.
Yeah. All right. So something you mentioned earlier, Todd, I kind of like taking this kind of big picture view of how do attacks happen, how do breaches happen,
Mhm.
and you pointed out exploitation of vulnerabilities is a smaller portion of
It's
it,
sliver.
and
Yeah.
and they're not even all malicious, right? Like there's a lot of accidents that happen. Like maybe we published something that wasn't intended to be published. Like there's a lot of misconfigurations. Maybe who is it? UpGuard that finds all the open S3 buckets and
Sure.
lets people know about it.
Yep.
You know,
There
and
is there is a worrying trend of so vibe coding. Let's talk about AI. Hey, check your bingo card. If you predicted that we would talk about AI within the first half hour, you just got under the line. Good job.
we're right at the
Uh,
30-minute mark, so that's better than
right.
most of the webinars you could be on right now.
So, I mean, we've seen some reports out there in the world of like, oh, check this out. It's clear that this thing was vibe coded because it's got like emojis in the comments and everything. And also they're just using static API keys everywhere because that's how vibe coding works, right? Like,
Yeah.
because vibe coding is just like, Stack Overflow with fewer clicks. And you will find examples on Stack Overflow. It's like, oh yeah, if you're going to write this thing in Python, right, you just do like API key equals API key, right? Like no business of like reading it off of a file or doing it in memory, or all the normal ways that you would move around API keys, like in like a CI pipeline or anything like that, right? And so like that, so that is yet another way, right, of just like accidentally committing your keys to some public repo somewhere, because you built some application, right, that uses that. So like there are myriad methods of getting that like initial compromise. Things like, oops, I've accidentally exposed like an entire subnet I didn't mean to, right, through some tomfoolery with my network segmentation, where this happens, I'd say, probably less often than it used to. It's not 0% of the time, but it's less often. I think a lot of the times, though, it's that user assist, right? Like I send you something, you do a thing on my behalf, and now I have, persistent access, at least through that touch point. And my first order of business there is twofold. One, I want to get root. I want to, like, if you're not already root, when you gave me that access, I want to get root. And then two, I want to be somewhere else now. I want to be able to spread. I want to be able to like have a bastion, ideally closer to the edge than I've started. And so I can just reliably come back in every time.
Yeah. Just mentioning that there have been several breaches that I have studied this year, because this is something I spent a lot of time doing, where the actual breach occurred in infrastructure that shouldn't have existed anymore. They migrated their production infrastructure to a new platform, maybe a third-party platform, maybe a hyperscaler or something like that, and never went back and shut down the old stuff. And HC, I don't know how often you see this. I know back when I used to do pen tests, I can't tell you how often I heard, "Oh, that shouldn't have been running anymore. That should have been gone."
Nothing ever goes away, right? Nobody wants to pull the plug on an old device because they don't know who's using it still. So it's kind of like leftover cloud assets or leftover cloud instances. Like it's really hard to know whether something is actually no longer used. And the older and weirder it is, the more likely it's going to stay there. Like, we run into things like old AS400s, we run into like tape backup library systems that are all incredibly vulnerable and exposed. But at the same time, like they're not going to go anywhere. Like you can't get rid of them because nobody's confident that it's not holding up some giant business process that nobody knows about.
I think that's one of the frustrations I've seen with remediation. Like when we talk about remediation, oftentimes there's a message that comes back says, "Okay, yeah, we fixed it." And one of the buzzwords that we're using here is continuous discovery. Continuous scanning is something that gets used a lot. Like how important do you think that is in validating that the stuff that should go away actually goes away? And I imagine the fingerprinting helps here to validate that that isn't a new gold image that somebody stood up from the same image. That is actually the same thing that you said you took down. Like is that easier with this approach?
Absolutely. You can say like, find anything that's running Windows XP or it's part of this domain or in this subnet range that has been last seen in this period of time, and it all pops up right away. So you can create little dashboard charts, you can set goals, you can create alerts for it. We have a customer that does a lot of customers do a lot of M&A using runZero, but often customers also do a lot of divestments. So they've got a part of the business that they've sold off and trying to disconnect from the environment. They have to make sure that stuff is actually gone. So runZero is like a really good way to make sure like, hey, this stuff should not be connected to us anymore. Let's make sure it's actually not connected. And more likely than not, it's still there. Like, 6 months later, we're still finding it. We're still reporting it. The other team is swearing up and down. They've disconnected it. We're like, no, here's the ping result. Like, it's right there. Like, so it's something where you kind of use runZero as the proof to go out there and tell people like, no, you missed something, try again.
And that is kind of the purpose of this thing, right? Is to be the system of trust, the system of record for validating whether or not these things have been fixed, or where the problems are, who the asset owner is.
Yeah, I mean, you could be a Microsoft shop and have Defender everywhere, but you don't necessarily want to trust Defender to monitor security for itself, right? You kind of want a different vendor, a different perspective to kind of make sure everything's working the same way. Unfortunately, it's kind of similar to vuln management. If you have a vuln management vulnerability scanner, you typically have only deployed it on a small portion of your environment. Like typically we see 50% or less of the total coverage for vuln management or vuln scanners. And there's a bunch of reasons for it. One, it's expensive to add a more license thing. Two, it can knock things over and crash it. Three, people add networks all the time. You don't know about it. So we kind of take the opposite approach of like with runZero, it's safe, it's fast, it's light enough that you can do continuous discovery all the time in the background. And we can quickly say, like, here's a subnet that you're just not covering with your vuln scanner, or here's a set of assets that are missing your EDR, missing another security control. So really helping you kind of close the gap on your kind of blind spots for security controls across the environment.
And then something else you mentioned, traditionally you would think as like something externally exposed, having a routable IP, exposed to the public internet through your corporate firewall or something like that. But you mentioned VPNs, and split tunnels, the ability to spot when a system is dual or triple homed or what have you. Is that something that you find often, like there are some of these weird network connections internally that end up exposing you more than you would think if you're just scanning your paid for external IP address space from the outside.
Yeah, I mean, I can tell you there hasn't been a single organization we've worked with that hasn't found at least one unintentional external exposure, even on a small network. It's almost guaranteed. Like there's no way around it. Like one case, the large university, they've got great firewalls, great security team. What they didn't realize though is the Anycast 6 and 4 tunneling protocol was actually being announced by their upstream ISP, caused all their internal networks to get a public v6 IP. And so it wasn't until they found the public v6 IP, and
that's kind of like an only at a university, like.
But that's like everywhere. Right? You find VPNs, you find, especially with all the hyperscaler stuff now, you got 5 different clouds connected together and you've got weird routing rules from different networks.
Yeah.
You'll see people like accidentally routing an Amazon VPC to a different network to another network, and keeping track of all those rules is chaotic. So unless you're actually testing and looking for it, it's really hard to know what reality looks like, especially when every admin may be changing something differently per site.
Well, and again, you're the system of record, and you have that fingerprint that says, "No, I actually talked to the service. Like I know it's exposed because I came from here and touched it here and made that connection." Right.
And timing, right? You can say, and it's 60 milliseconds away. We know it's not in the same building, just by definition.
Yeah.
It's either a really slow device or it's really far away from us right now, just by looking at the latency on it. And so you can sort like your runZero results based on RTP and say like what's close, what's far away. You can even build like these neat kind of grid reports. We show like the subnet grid report and then color by RTT. You can show like what are things that are unexpectedly slow in the environment, and then figure out, oh, that's actually a port forward, or that's actually being routed someplace else and back.
Mm-hmm.
So something I don't really understand. I do use the community edition of runZero, but I don't use it to scan from the outside. So I want to better understand. Do you just find an external system to run, install an Explorer on, or do you guys have hosted Explorers? Like I know most vulnerability scanners will have hosted scanners that you can select to run your scan for you. How does that work from outside in with runZero?
Absolutely. Even our free version has hosted scanners. So you can just go into the console, create a new task, tell it to scan an external IP, pick hosted scan engine. It'll typically be like New York as our main data center for it. And it'll just scan you externally from a random IP externally. Also kind of neat, you can tell it to expand a domain automatically, or an ASN or anything like that, or country. So you can say like, I want to find everything in my domain name. So domain:runzero.com. We'll go look at passive DNS databases, do subnet expansion, find all your stuff, and then scan it all. and it's just kind of a single shot, off you go, which is kind of nice. You don't have to go do the subdomain detection on your own. And even for a home network, right? You can say, if you've already included some public IP space in your scan, you can actually tell the scanner to then scan all of your public IP space just by saying, public : all, I think is the keyword for it in the scan engine. That'll scan all your public IPs externally. So even if you're adding new external IPs all the time, it'll be constantly scanning whatever those new external IPs are. So you make it really easy to kind of keep up with your external exposure. And of course, you can then create rules and filters and tagging, all kinds of fun stuff on that point.
Yeah, like you, Adrian.
Things to do as soon as we jump off here.
I also run runZero at home. I started shortly before I started working here, maybe 6 months or so, and yeah, I've got I'm a citizen of the internet. I've got some rinky-dink websites out there, and so I just kind of I'm like, oh, I've got 100 assets to go. Okay, well, I've only got like maybe 20 in my house. I've got so much room for activities with this free license. So I can add like all my packet foo stuff, all my huge success stuff, like all the other goofball hobbies that I have out on the internet. It's super fun. I highly recommend it.
Yeah, same here. So the other thing I don't know a whole lot about that I wanted to hear more about is runZero Hound. Is what this tool is that from the name, I presume it's something forked from Bloodhound.
Oh yeah, we're big fans of Bloodhound and doing graph analysis. So we do some stuff in the product today. Like there's a layer 2 topology. You typically start off with like a list like this, what your assets look like, and then Todd, if you can go to the next slide real quick. This is kind of if you look at the network from a layer 2 topology aspect, like what switches are connected to what things physically. We can build this table for you based on ARP caches, MAC tables, VLANs, things like that. And taking a step further, next slide, please. This will show you kind of those layer 3 routes, including the unintentional ones. So you can see that a lot of the nodes here have lots of connections coming out of them, like this OpenSense device in the middle. That's actually the firewall. It's supposed to be connected to everything else. Nothing else here is a firewall, and yet a lot of these have more than one leg hanging off of them, which tells you how much interconnectivity there is. So you can see a lot of cases where devices are bridging 2 networks together. They could basically become a router for it. So these types of graphs are really helpful to say, like, is there an external entry point to my network someplace I didn't expect? Like another red circle up here, that's an external range tied to an asset. In a large network, you'll see those red circles everywhere, tons of external ingress. So what we want to do is say, great, let's take this one step further. Can we find vulnerabilities that are only discoverable by the relation between 2 distinct assets? And we thought that the Bloodhound tool, they've got a community edition, so it's free if you want to play that, also enterprise. They created this cool thing called Open Graph, which is a way to basically bring arbitrary data into Bloodhound, just like we have arbitrary data into runZero. So we created an open source connector that takes your runZero export and then turns that into a Bloodhound graph, and then basically imports that and links it all together. And you can basically ask some really cool questions. So you can say, like, show me everything where there's a connection from the internet to my internal network, straightforward network sense. I think probably the next one would show that off a little bit. But effectively, you can start overlaying these things. In this case, is there a path from the internet to any IP that starts with 10x that runs remote desktop? So internet path to RDP on this particular internal network. Pretty straightforward. That's an easy one. Next slide. So this gets a little bit trickier. This is like one of the few questions you can't really answer unless you know a lot about the environment beforehand. So let's say you're walking to a brand new environment and you say, okay, I want to figure out, is segmentation broken here? So what it does, it says, is there a BYOD device anywhere in the environment that's on the same subnet as a Cisco device with a default SNMP, or in this case, an OT device that has a protocol like BACnet or Modbus open? So is there some way to go from BYOD, like, is my iPhone on the same network as a device speaking OT protocol? That's the problem. Now, granted, you could do the same thing if you knew what your OT networks were ahead of time. Obviously, it's straightforward to go look for this stuff. But if you're going to an environment where you're not even sure what networks have what OT devices on them, this is a great way to say, like, should these devices ever be together or not? And so it's kind of a new way to look at the world. So we think Open Graph is awesome. We're going to continue contributing to ways to bring data into Bloodhound and vice versa. We're looking at ways to do more of this graphing in runZero natively and then work with Bloodhound as an integration. So we think it's just a really cool kind of open source playground right now. And if you want to download runZero Hound, you can like tweak the edges and graphs and take pretty much any attribute in runZero and turn that into an edge in a node. So we track things like VLAN, subnet contains, any relationship internally you can then map out, including domains and stuff coming in from third-party integrations.
And that BYOD.OS, is that something that's defined within runZero, or is that something that I custom define what that means?
In that case, the query was we just called the device BYOD in the graph, and then we look for OS equal iOS or Android. So you're just putting it directly in there. You could also just do .type equal modal, or sorry, BYOD to .type equals mobile would be another way to get there. So pretty much any attribute in runZero, you can then filter on in the graphs. And again, most of those queries also work on runZero. It's just kind of cool to be able to see it in the graph level and be able to do that kind of. In runZero today, you can't say find me every BYOD device on the same network as another device. There's no way to link those two yet. And that's kind of the unique thing that Bloodhound lets you do. But that's an area that we're looking to expand, is how to build better attack graphs in runZero and also do these really cool relational vulnerability analysis.
Yeah, because first thing I thought is I bet I find ties in like LG OS, WebOS smart TVs and Samsung smart TVs and stuff like that on OT networks.
That's amazing.
On OT networks, or just like in your normal kind of user land, right? In conference rooms.
Well, everywhere, right? Yeah.
Can
you even buy a non-smart TV anymore, right?
You can't. Well, no, but you can fail to plug it in, right?
Yeah.
Like,
and they still come with Ethernet as well, so you can still directly plug one into a network without Wi-Fi.
Yeah, those are scary things. Like they can do content detection from the microphone. They can do motion detection. So a lot of stuff. Even if you have things disconnected from the internet, it's still doing stuff. Like
if people didn't know, smart TVs have microphones on them. Yeah, some people may not know this, right?
They often have motion sensors, like kind of a presence detection, all kinds of stuff like that, lighting detection. So you don't really get a better spy device than a TV in your bedroom.
Yeah, that's scary stuff. All right. So with 15 minutes left, I want to remind people they can drop in questions here, or you can just download runZero and start playing with it, like some of us have. What else did we want to cover here? Let's see. So you had some slides. I don't think we've shown this yet, just showing what exposure management looks like in runZero. You have a dashboard for this?
Yeah, absolutely. Let's see. That looks like slide.
It's right before the runZero Hound stuff.
Oh, okay. Gotcha. Thank you. Yep.
So our goal at runZero, like in the early days, is really about just find all your stuff. Then became find all your stuff even outside the network, including all your integrations, third-party cloud, et cetera. And then we realized that the most important thing we're doing for customers is helping them to avoid ending up on a ransomware site, like helping them quickly identify a thing that's going to get them in trouble if they don't solve that second right now immediately. And so we've been building this kind of optimized pipeline. So if a new vulnerability comes out, and let's say Next.js, like the one that came out today, we can immediately look at everything already in the environment that you already have. You don't have to run any more tasks, match everything running Next.js that we know is exploitable because it came out today, and then get an email in your inbox immediately saying, here's the devices that are currently affected, especially ones that are internet exposed, and hopefully give you enough of a heads up you can resolve it before an attacker runs across it and take care of it. So we've been moving more from this inventory-based view of the world to a very risk-based view of the world. And of course, you can go both directions. You can go in the inventory, you can do whatever you want to there, you can build whatever security program you want, but you can also now use our built-in risk dashboard to get kind of a pre-canned security program for things like top findings, things like that. What we really try to do is make sure that we bubble up the stuff that's important. Like we don't just want to ingest a million tenable vulnerabilities and tell you, oh, you should care about this one, because you may not need to care about any of them. You need to care about something totally different that's not even tenable at all. So what we try to do is roll them up into a finding, which is kind of a categorical grouping of different types of vulnerabilities that are related, and then do really good analysis to say this one's more important, less important, and so on, and allow you to go through and actually mark those as suppressed, unsuppressed, et cetera. So the vuln suppression stuff and finding suppression work will go out, I think, next week. So we're excited to allow people to kind of build a better workflow there. But we're very much about focusing on, you have to build that base of everything in your environment first, but then it's very much about preventing you from having a breach, preventing an incident from happening. And when an incident does happen, figuring out what the blast radius is and when the device joined the network, who's connected to it, what users involved, all that fun stuff.
Yeah, and just compliance stuff as well. Like I've been giving a lot of in-person talks at IANS forums about post-quantum crypto readiness. And under inventory, there's a certificates item under there, and you can look at all the certificates and see how ancient. Like that, I found that's a really good way to find really old devices. Also,
we still see in the wild.
Yeah, it's amazing. And yeah, so where was I going with that?
As far as finding old stuff on the network. just two things, and I promise I'm not going to talk your ear off about end-of-life operating systems. I think I did that the last time we got together, Adrian.
Yeah.
But EOLOS that is actually kind of a huge finding because it will tend to mask other vulnerabilities behind it. But I know our director of applied research here, Rob King, has been noodling around with like, well, what's a good way to find old hardware based on like when the MAC address was first minted. And it turns out, and I know HD has done some stuff in this area as well, but we're looking at trying to pull some of that out and see what more we can do with that, right? Because like, brief surface scans of just like stuff that's hanging out on the internet. Like we'll find MAC addresses that are 15 or 20 years old.
Yeah.
That's hanging out on the internet.
and that's one of the top metrics that I recommend to folks with their vulnerability management programs and asset management programs is asset age. So there is a question of how do you determine asset age? Is it when the OS is installed, how old the hardware is? And I think the answer is kind of all of the above. But generally we find
like we're worried about, like mechanical stress or heat or anything like that, right? Like, but we do see a pretty strong correlation with like, if something is hanging out and it's like over 10 years old, it's probably kind of rickety. It probably doesn't have like any of the modern controls that you might expect to find. Less likely to have been like updated through its life on new operating systems and new like builds and all that stuff. So like it tends to be a pretty good hint.
One of the most surprising things I found when testing all the external attack surface management vendors years ago was one of them looked at the footer on a website for the copyright. And if the copyright said 2013, that was a critical. That would write like that's something a vulnerability scanner would never even look at, right? Sure. But yeah, is there any time where a website says copyright 2013 and you don't want to know about it, right?
Good point. Another one is the last modified header you get for static assets. It's kind of similar. You get the last modified header of an admin portal to something, and it says 2019 or 2018. You get the same problem. Like this device is ancient. The UI has been updated forever. So the footer is great for that for copyright, but you can also look at other metadata coming back from the site to detect that stuff.
Yeah, even if you're not actively finding vulnerabilities on it, the fact that it's that old, you still want to go take a look at it. It's probably vulnerable to something. It probably has some default credential on it or old credential on it. Like the likelihood, I think, becomes much higher the older it is.
Something that I just want to give a shout out to a company called VulnCheck. What they've been doing is getting data from Shadow Server and finding vulnerabilities that are being exploited in the wild that don't have a CVE. So a lot of security programs are very CVE focused. If you don't have a CVE, you can't do anything with it. So they've been going through and backfilling all these old exploitable IoT device application vulnerabilities and giving them CVEs now, which is hilarious. They're now like one of the biggest CVE issuers, but for historical active exploited vulnerabilities. So it's exactly the kind of case. You find an old device, you realize people are actively exploiting it, then you also realize there's no CVE for it today. So none of your vuln scanners know about it, and then they're doing a good job of backfilling those bugs.
Totally true. Like EPSS won't give you like the input for getting an EPSS score is the CVE number, right? So like a lot of vulnerability management programs kind of fall over without that key indicator. So one of the things I wanted to ask is, so clearly you can do a lot with the product. It can give you a lot of information about your attack surface, but how are people actually using it? Like on a day-to-day basis, because we're talking about scanning continuously. This is probably something when you're drinking your first cup of coffee, you should be looking at something. Is that a dashboard in runZero? Is that a report that gets emailed to you? What is keeping up with your assets and spotting some of these routing mistakes or whatever it might be? Like what does that process look like? How are customers discovering this stuff using the tool?
Sure. Like day one is asset discovery. It's day one is like, let's make sure everything we have is actually in one spot and we know where it is. So connect some integrations, connect your EDR, your vuln management, any cloud stuff you have, and then start running like RFC 1918 wide scans and make sure like, okay, everything that I have is actually under management. We know where it is and so on. And that's very much just kind of like, what do we actually have? Kind of day one stuff. Day two is typically great. Here's our security goals. We need to get rid of all of our end-of-life operating systems. We need to make sure nothing is no longer in the sole domain. We need to make sure no devices still have a default password set. We do default login checks. We need to identify anything that meets this criteria as being an end-of-life asset or an older version of a web application. because you can search for almost anything in the product, and then you can turn any search into a widget, an alert, and a vulnerability. You can create your own vulnerability management program by saying, here's an internal app that no one else in the world knows about, but I can actually use a search query and runZero to create a vulnerability and set the risk of assets based on it, and build like your entire custom vulnerability check program if you want by hand, if you want to go that direction. So usually we have customers saying, one is visibility, two is getting all your security goals set up and automatically tracking and queries and dashboards and tickers and whatnot. And then you usually set up alerts. So when either a goal is missed or a goal is reached, you get an alert telling you what happens. And then, going forward, it's a whole broad set of use cases. Compliance, like, do we meet the compliance for knowing where all of our assets are? Yes, you got that. Do we have any devices that are outside of our support window EOL? That's pretty straightforward to measure. And then we support a huge range of secondary use cases, everything from IT, where we're pushing data back into ServiceNow. So you have the other half of your assets that ServiceNow doesn't know about, that their scanner can't find. We'll give you all those. Or cases where it's very much incident response based, where somebody is inside Splunk or your SIM of choice, and we're pushing runZero data into that SIM, and they're using that data to figure out, okay, what was on the network, when, where, how, when this incident happened, what could they reach, where could they have gone, where they come from. So we support a ton of kind of secondary use cases. And then kind of the day-to-day is very much like, is there something new that I didn't know about before? Is there something exposed to the internet or something that's like high risk that I need to take care of this second? And that's kind of like your injection work, if you will. But typically every customer has a slightly different security program. One of the fun ones we worked with are identifying like unauthorized KVMs in the network, things like TinyPilot and Jet KVM and stuff like that. Another one that was really fun was identifying Section 899 hardware, like Hikvision, ZTE, Huawei devices, because a lot of the US manufacturers like Amcrest just rebrand the Hikvision chipsets or the Amcrest chipsets. And so technically you're violating the compliance of Section 899 if you have an Amcrest US made device, because it really is just a rebranded Chinese device from one of those manufacturers. So it wasn't until like this year that the manufacturers finally started owning up to the fact that, sorry, these devices are not compliant because we're rebranding these Chinese vendors. And it wasn't until really this year they started taking that seriously. So what we've been doing at runZero is identifying the underlying manufacturer for these devices. Even if the thing is labeled as an Amcrest device, we can tell you it's really a DeHoot.
Yeah. Good stuff. So I think we have one final question there. Somebody's asking if there's integration with Oracle Cloud.
We had to request for it, but we don't have a ton of users for it today. I think it's pretty easy to create a custom integration, but we'll probably build that one natively. It's just kind of a question of getting some time for it. But yeah, happy to chat about it.
Cool. If there's no other questions, final thoughts before we wrap things up, Todd and HD?
If you have any interest at all in like network mapping, having an idea of what's on your network, like I cannot recommend runzero.com/try. I cannot recommend it more. It is super fun. And you can get nerdy with it. You can just let it run. I have mine set up to like alert me when a server goes down in my house before my kids start complaining that they can't watch TV anymore. So yeah, like the free trial entry is just it's a delightful experience. And of course you shouldn't believe me. I work here, but I was doing it before I started working here. So I want some credit.
I'd say the same thing. If you work for a company and you can't use a SaaS-based solution for this stuff, like we have a fully self-hosted version, and it's not some giant nasty virtual machine that's out of date. We actually give you an installer binary that you put on whatever OS you like or whatever version of Linux at least you like. So if you do have a like offline environment or you can't do a SaaS trial for the stuff, just reach out to our team. We can set you up as self-hosted. Like we ship
the
actual
whole thing's written in Go, so it'll compile on basically anything.
It's
this is not a dare. It's kind of a dare.
One neat trick is you can actually take the runZero Explorer or a CLI scanner and drop it on a compromised IP PoE camera and actually run your scans from that camera or from a compromised desktop. So we're really popular with like pen testers as well, just because my background is very much outside. So it's very pen tester friendly, put it that way.
Yeah,
I love it. Love it. Yeah, it's I use it as well. My favorite game to play is how many assets do you think are on the network? And then you run it and get the actual number.
Let's revise that up maybe 20-25%.
Yeah. Usually people are off by an order of magnitude in my experience. At a zero. Yeah, they'll think about phones and laptops, but completely forget about all the the voice assistant devices. The smart stuff, the smart home stuff.
Honestly, building equipment in an office building, right? Like that will show up as well.
Yep.
Yeah, folks
Yep.
often misconnect networks. Like there's been a lot of some of our customers, like a large national zoo or a large zoo, their internal network was cross-wired to the ISP's internal network. So they ran a scan, they discovered 800 ESXi servers. They're like, we don't have ESXi servers. Like, why is it on our internal network? Well, ends up they had a straight route to a 10x network to the ISP. And so they had bidirectional communication from the internal of the ISP network to the internal of their network. And that was a fun finding. We actually see that quite a lot with residential networks where someone will run a 10x scan on a residential network and then find all of the ISP's internal stuff.
Oh, amazing. That's crazy. Yeah. Yeah. How do you, I wouldn't even know who to call. That'd be interesting. All right, Todd and HD, thank you so much for joining me today. I had a blast talking with you about all this stuff.
Thanks, Adrian.
Cool. Yep, same. Always a pleasure, Adrian.
Thanks to our sponsor, runZero, for making today's webcast possible. Don't forget, we do have a PDF takeaway that you can grab there. Of course, the other takeaway is just go try out runZero. And big thanks to the audience for joining us. Thank you for all your questions, all the engagement in the chat. It's my favorite thing to see, and we will see you next time.